Today we would like to talk about a very popular tool in machine learning, which is called decision tree. Decision tree is a decision support model and it is used in a variety of different areas, such as decision analysis and machine learning. Our goal in this project is to build a decision tree model to predict the mushroom dataset. Let's consider an example of decision tree. You can see here at the top of the tree, we will have root. It has the highest position and other nodes are on its descendant. And the one with have no children like this file are called leaf and it will contain the value of our predicted data. To understand how decision tree works and how to use them to predict the class value, we will consider an example. A is equal to young, credit training equal to fair, and student equal to yes. So we will begin at the root of the tree and we want to move forward until we reach the leaf of the tree and return its value as our predicted data. So when we want to move from one node to another, we will move from the father to the children and we will consider the attribute of the father, which is 8 in this case, and consider our value in our example, which is young. So we will move to this node because it had 8 equal to young. And similarly, the same process is repeated until we reach the leaf of the tree and we return the predicted values. So how can we build decision tree? In reality, there are many different algorithms to use to build decision tree. However, in our project, we will use ID3 because it is a very simple and straightforward algorithms. To understand how ID3 works, we will consider a very simple dataset, long decision. It has three different attributes, 8 student and credit rating, and 6 different cases. In order to build our decision tree, we will first create the root node which have all the features and cases of our dataset. And from the root node, we will continue to build each children and each children until one of these three conditions are met. The first condition is that all of the class value of a node convert into one value, which means that the node cases only contain one class value. The second condition is that there is no more features, and in this case, the node value will be the class values that have the most occurrences. And similarly, if there are no other cases, we will use the class value which has the highest occurrence. So now the problem is simplified into how to build a node children. In order to do that, we will need to choose an attribute from the node attribute set and but which attribute to use. We will choose the one that have the highest information gain. Information gains is the value that is calculated by the entropy of the dataset. And after we split the dataset into different parts that corresponding to the attribute values, we will now have the children of the nodes. Let's apply our algorithm into our dataset. So first we will have the root node that contains all features and cases. And now in this case, 8 is the attribute that has the highest information gain. So we will split the dataset into 3 different parts based on the age value, young, middle, and senior. And the second node has just one value, which means that it has one class value. So this will be considered the leaf of the tree and we will stop process this node. For the first node, because the class value haven't been converged, so we will continue our process, and the next attribute is chosen is student, and we will split it into two different boxes. And right now it's the class value already converged on both of these nodes, so we will stop, and similar to a equal to senior, the attribute has been chosen ready. When implementing the algorithms, we notice a problem is that what if an attribute value only appear in the testing set, but it does not appear in the training set? So how can decision tree predict the value? To deal with that problem, we will create a new node that have the value equal to question mark, and right now we can classify all of the unknown value into the question mark node, and the problem is solved. So here's our implementation for the algorithms. In our implementation, we have three different class features which contains all the information about the features, including the values of different cases. And then we have nodes class to store the value of the node. And lastly, we have decision tree. It has the value of the training set and the root node. So in our implementation, first we will read the dataset and split it into two different parts, the features one and the class label. And then we pass these two into the decision tree to create a model object. And then we will read the testing set and do the same with the training set. And then we will display the tree and predict the value of the test set with the tree that we built, the model tree that we built previously, and then display the confusion matrix. This is a demonstration of how our program will work in real life. So we will use command line to run the program, and as we can see, first it will print out the tree presentation, and it's begin with the root and its value, and one node children will have a start, yeah, one more tab at the beginning of the line compared to its father. So this is the children of the root node, so it will have one tab more than the root, and similarly to this one, it's either children of this one, so it will have one tab. And the boundary of the one node the descendant is from this one to the one that have the same tab as this. So this is on the descendant of this node. And at the end of the result, we will have the confusion matrix. In this project, we already learned how to use the decision tree in real life, how the decision tree works, and how to build a decision tree. Also, we learned how to deal with the missing value and on the edges case of the decision tree, such as what if a value of the attribute only appears in the testing set but not the dataset. And next time I do this project, I will have more experience, and so that in designing the algorithms as well as the data structure used to do these algorithms. If I have another chance to do this project, I will have a pattern naming variable system, because as you can see, this variable name is not a very good way to name it. And in our project, for the ease of implementation, we use a lot of built-in function of Python, and it will slow down the program very much, because such as this one, I can check this one appear in the features here, in the first look, but I still use a in function, which will eventually slow down program very much. And if I can do it again, I will build my own solution instead of using a lot of in function of Python.